Well, today we're going to kind of relate the Pythagorean theorem to some triangle inequalities. So we're going to discuss again the relationship between the lengths of sides of triangles and also pull in the Pythagorean theorem. So remember from way back towards the beginning of the year, and we used this to find distance, that if a triangle is a right triangle, then it has this relationship. The two smaller sides, A and B, if I square them, so if I square A and I square B and I add them together, it'll be equal to the longest side squared. So if I can take three side lengths of a triangle and I can plug them in for A, B, and C C is always the longest one, if my left side when I simplify it is equal to the right side when I simplify it, then my triangle is a right triangle. So we can also use the Pythagorean theorem to determine if a triangle is obtuse or acute. So if it's obtuse or acute, then it's not a right triangle. An obtuse triangle, remember, has one angle that's bigger than 90 degrees. And an acute triangle has all angles that are less than 90 degrees, so acute angles. So we might take the side lengths of a triangle and plug them into the Pythagorean theorem, and both sides might not be equal. In that case, I either have an obtuse triangle or a acute triangle. So if my larger side squared is bigger than the other side, that's two smaller ones squared added together, then my triangle is obtuse. If my larger side, C, when I square it, if that's smaller than A squared plus B squared, then it's acute. So just a quick reminder, this symbol right here, that's the less than. So what this saying is A squared plus B squared is less than C squared, which means that C squared is bigger. This symbol right here is the greater than. So this means that A squared plus B squared is greater than C squared or bigger than C squared. So C squared would be smaller. So again, if the right side, C squared, is bigger, then it's obtuse. If C squared is smaller, then it's acute. So let's try this. We might be asked to take three side lengths of a triangle and figure out whether it's a right triangle, an acute triangle, or an obtuse triangle. So the only other way to have done that would be to know what the angles in a triangle are. But in this case, we don't. We only know that one side's 4 meters, the other side's 5 meters, and the third side is 6 meters. So we're going to start with the Pythagorean theorem. And I don't know if the sides are going to be equal, less than, greater than, so I like to put a question mark between A squared plus B squared and C squared. Okay, because I don't know what the relationship is yet, and in fact, that's what I'm trying to figure out. C squared is always the biggest side, so I need to find the biggest side, which in this case is 6, and I plug it in for C. And then the two smaller sides are A and B. It doesn't really matter which one's A or which one's B. I'll just put them in like that. You could do 5 squared plus 4 squared, you'll get the same result. So now we need to simplify the left side, simplify the right side, and figure out what symbol to replace the question mark with. So 6 squared is 36, 4 squared is 16, 5 squared is 25. Now we can figure out which side is bigger. My left side is 41, my right side is still 36. It looks like my left side, A squared plus B squared, is bigger my c squared is the smaller of the two sides. When c squared is the smaller of the two sides, then it's an acute triangle. So again, since c squared, 6 squared, is smaller than the other side, a squared plus b squared, it's an acute triangle. That means if we knew all the angles, they'd all be less than 90 degrees. So pause here and see if you can determine whether or not it's a right triangle, an obtuse triangle, or an acute triangle. So when I'm asked this question, I'm always going to start by writing down the Pythagorean Theorem. And again, remember, in this case, we don't know if a squared plus b squared is equal to c squared, bigger than it, smaller than it, so I like to use the question mark, because that's what we're trying to figure out. The biggest side in this example is 26 feet, so that goes in for C. And then A and B are the other two, the smaller sides, so I'll use 10 and 24. Again, if you did 24 squared plus 10 squared, we'll get the same answer. So we'll simplify these sides. So my left side turns out to be 676. My right side is also 676. Those two numbers are equal to each other. Since both sides of this equation are equal, I have a right triangle. So this triangle will have 190-degree angle and be a right triangle. So kind of a short lesson. I have one you-do problem for you to do. Tell me whether this triangle with sides 15, 20, and 24 is a right triangle, an obtuse triangle, or an acute triangle. Do it so you can ask questions, you can check your answer, and you can practice confidently.